Welcome to another episode of The Brand Called You, a podcast and podcast show that brings you leadership lessons, knowledge, experience, and wisdom from thousands of successful individuals from around the world. I'm your host, Ashutosh Garg, and today I'm delighted to welcome an accomplished leader, a senior and respected professional from the world of academia, and an author from California, USA, Mr. Gaurav Suri, or Professor Gaurav Suri. Gaurav, welcome to the show.
Pleasure to be here, Ashutosh. Thank you.
Thank you. Gaurav is a distinguished scientist at Stanford University. He's an associate professor at the San Francisco State University. He's director, readiness, activation, and decision making laboratory, which is RadLab, co-author of a book titled The Emergent Mind, and I'll be speaking about his book today. And because of the incredible work he's been doing, understandably, he's the recipient of numerous awards, honors, fellowships, and research grants. So, Gaurav, before we come to your book, a few questions for you. You began your professional life in consulting and entrepreneurship before turning to neuroscience. What prompted this shift from business to brain science?
Yes, thank you, Ashutosh. I think that it's every person has a nature,
Mhm.
and this nature dictates where they're going to find happiness and fulfillment, and where they're going to be motivated.
Mm.
And my nature is that I'm a philosopher and a scientist. I knew this from a long time ago.
Mhm.
I went to modern school in Delhi.
Mhm.
And my friends, there were two of my friends there who were really good at mathematics. And you know how when you're in an impressionable age, if your friends are doing something, you want to do something too.
Correct. Correct.
So my parents wanted me to be a doctor.
Yeah.
I said, no, I'm going to be a mathematician.
Mm.
So I started doing my PhD in mathematics,
Mhm.
I realized that I could be an okay mathematician, but there are other things in the world. And in my 20s, there was an imperative to, go see the world, make money, etc. I became
Mm.
a consultant. I'm a decent teacher, and consulting is all about teaching. But those longings from my nature, which is a philosopher and a scientist, never went away.
Mm.
So in 2007, the school friend Hartosh Singh Bal, who is
Mhm.
the editor of Caravan magazine in India, he
Mhm.
and I wrote a book called A Certain Ambiguity,
Mhm.
and it was a mathematical novel. And I was still working in consulting,
Wow.
and I wrote this book, and I thought, wow, this was so much fun. I love to write and I
Mm.
love to think. And by then, Ashutosh, life had been kind. I was at a place where I could consider leaving my job and going back to school. So in
Mm.
middle age,
Mm.
partially because of fate,
Mm.
I'd happened to live near Stanford
Yeah.
University.
Mm.
I did my PhD at Stanford University in a field that I really hadn't uh, delved into before,
Mhm.
neuroscience decision making. Um, And then from that, I became a professor, uh, stayed in the Bay Area because my family's here, my friends are here. So taught at San Francisco State University
Mm.
and took the research job at Stanford as well. So
Mm.
that's the arc of
What an
my
amazing,
life journey.
what an amazing journey. Thank you for sharing it. But then, what was also fascinating when I was reading about you is that you studied both mathematics and psychology. How do these disciplines come together in your work on understanding the mind?
Yeah, great question. So, psychology when I was growing up was sort of a fuzzy science, maybe
Correct.
not even a science, right? And mathematics sometimes is called the queen of the sciences because it's
Correct.
very precise and
Mm.
everything leads from one point to the next point. And when I was doing my PhD, I met a man called Jay McClelland,
Mhm.
and he should win the Nobel Prize several times over. He's quite a scientist. I had the good fortune of meeting him. And Ashutosh, I came back to uh, PhD program in my midlife to ask
Mhm.
the eternal questions. Eternal questions: Who are we? How does our mind work?
Mm.
And the answers I was getting were not satisfactory until I met Jay McClellan and he introduced me to neural networks.
Hmm.
And neural networks are a way of thinking
Hmm.
about how it's possible that the mind has properties, even though it's composed of units that don't have those properties. The mind can think, the mind can feel, mind can have emotion, the mind can
Hmm.
decide. But if you look at each individual neuron in our mind, it doesn't have the properties.
Hmm.
So this is called an emergent system in which the whole has properties that the parts don't have.
Hmm.
And understanding neural networks is somewhat mathematical, um, and it fits in psychology.
Hmm.
And this was a very natural fit for my nature. My training is in, well, early training is in mathematics.
Yeah.
And I was asking these eternal questions about the mind, which weren't getting answered by traditional methods in psychology,
Amazing.
but then were answered to my satisfaction with neural networks, which sort of lie on the edge between
Correct.
computer science, AI, biology, and psychology.
Fascinating. What a great response. And this gives me an interesting segue to move to your book, The Emergent Mind. Your book opens with a childhood story about your own indecision. Why did you choose to begin such a scientific work with something so personal?
Yeah. Well, thank you for asking about the book. Here it is. It's
Yeah.
called The Emergent Mind.
Yeah.
Its subtitle is How Intelligence Arises in People and Machines.
Machines.
And it's by me and Jay McClellan, who I spoke
Correct.
about a second ago.
Yeah.
And you're
Yeah.
absolutely right. The first line um, in chapter one is when one of the authors of the book, Gaurav, meaning me, was 14, his parents gave him the equivalent of about $50, which was a lot of
I know.
money,
Mm.
for his birthday. And this could have been a trip to Rajasthan, school trip to
Mm.
Rajasthan. I
Mm.
think it was Silisere. I don't
Yeah.
know if you've been to Silisere.
Yeah.
The cash was enough to buy denim bell bottoms, absolute must-haves for any teen at the time, or enough to reserve a spot on a long four school trip.
Mm.
The reason I started with this, Ashutosh, was because this episode, I found myself constantly vacillating about how to spend the money. Should I go
Mm.
on the school trip or should I
Yeah.
buy this fashionable piece of clothing? And what fascinated me was that in the morning I would think, oh, I should maybe go on the school trip. In the evening, nothing had changed, but my mind had changed.
Mm.
And I remember thinking that it it can't be quite a computer because a computer cannot change its mind
Correct.
without the outside information changing.
Yeah.
And it was a childhood moment where I sort of became interested in what is the mind and how does it reach these decisions and how can
Mm.
we understand it? You know, in India we have a concept called Atma,
Hmm.
right? Uh, Somebody's Atma defines what they do. But and this is a beautiful concept. I'm not
Yeah.
rejecting the Atma, but for me the question is, well, that how does the Atma know, right?
Correct.
Ascribing it to the Atma doesn't solve the problem because you
Mm.
ask the same question about the Atma. How does
Yeah.
the Atma know? And if your answer is, well, the Atma just knows, uh, as a scientist, that's not a satisfactory answer. So this episode that you nicely talked about for me led to this journey
Mm.
of inquisitiveness about what is the mind and can I understand the mind.
Mm. 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 Amazing. Amazing. The central idea of emergence runs through your book. For our listeners and viewers, tell us, what does emergence truly mean in the context of the mind?
Absolutely. I must appreciate your questions. They're beautifully ordered and
Thank you.
very precise. Thank you.
Thank you.
So emergence is a property that's present in the whole,
Mhm.
but not in any of the parts.
Mhm.
Okay. So let me give you an example. If you take a group of ants, right? So I'm actually going to show you a picture of this phenomenon.
Mhm.
If you
Yeah.
take in the top panel, if you take
Mhm.
that group of ants, imagine they're going from a nest on one side to the
Mhm.
food source on the other.
Mhm.
And imagine you put an obstacle
Yeah.
in their way.
Mhm.
Initially, half the ants go the short way around the obstacle,
Mhm.
and half the ants go the long way around the obstacle.
Mhm.
But in about 15 minutes, almost all the ants are going
Mhm.
the short way. Now,
Right. Wow.
now the question is, how does
Mm.
this happen,
Correct.
right? So when I ask people this, students, they will say something like, oh, the ants are communicating to each other that this one is short, that one is long, take the short one, it's more efficient. Ants are remarkably stupid. In each
Hmm.
individual ant is remarkably stupid. It has
Hmm.
no conception of distance, nothing that it can tell other ants by looking at that other distance, nothing.
Hmm.
And yet ants can do this. So the question is, how can ants do this? And the answer is that ants do two very simple things.
Hmm.
They lay pheromones and they follow pheromones.
Wow.
So
Okay.
so let's imagine there's these two ants, and one ant takes the short way, one ant takes the long way.
Hmm.
Okay? Who gets there first? Well, the ant that took the short way gets there first.
Hmm.
Right? Now it faces a decision. Which way should I go back?
Hmm.
Now, which way should it go back? Well, it laid pheromone trail here. There is no pheromone trail here.
Hmm.
So it goes back where it smells the pheromone.
Right.
Now that other ant finally, Bhula Bhatka, gets there and he has a choice. Which way should I go back the way I came or should I go back this way? Now
Hmm.
there are two trails of pheromone here.
Hmm.
This ant coming and this ant going.
Hmm.
There's only one trail of pheromone here,
Hmm.
which is this ant coming. And so this ant also goes back the short way.
Wow.
You see, so what happened here is
Hmm.
no ant understands things about the short way or the long way,
Hmm.
but as a system, they understand this. And the core idea of emergence is that these are properties that are present in the system, but
Hmm.
in none of the individual parts.
Wow.
And the reason this is important for me
Hmm.
is it turns out, my thesis is that the brain is an emergent system. We
Hmm.
have about 100 billion neurons. The neurons themselves don't know how to think or what a thought is or what mathematics is or what poetry is. But working collectively, they lead to the emergent mind.
Hmm.
And so the emergence is this property which is everywhere in the universe. The
Hmm.
wetness of water is emergence. If you have a single molecule of water, that's not wet.
Correct.
But sheets of water sliding on each other give us the sensation of wetness.
Wet.
Emergent property.
Correct.
Galaxies are emergent. Evolution
Correct.
is emergent.
Correct.
Emergence surrounds us. And for me, a metaphor for our own minds is that we are a colony of ants, an
Hmm.
emergent colony of ants.
How incredible. And therefore, my follow-up question for you, Gaurav, is how does the emergent mind redefine what it means to be intelligent, both in
Yeah.
humans and I'll add another aspect in machines?
Right. So, Ashutosh, I'll take the second of your two questions
Okay.
first. It turned out that humans have tried to build AI systems for now getting on 100 years. Well,
Okay.
actually, even before that, Charles Babbage had
Hmm.
an analytical engine. But really, nothing worked. AI
Hmm.
did not work because our instinct
Hmm.
was to make AI by if then else statements.
Hmm.
If this happens, do this. If this happens, do this. No matter what set of if then else statements we came up with, the rules we
Hmm.
came up with, they
Hmm.
were insufficient to give this thing the intelligence. Now, and a large language model like ChatGPT, you could tell it anything in a
Yeah.
response,
Yeah.
right? You can't do this with rules.
Hmm.
Now, it turns out that the ChatGPT and other large language models are neural networks
Hmm.
like our brain.
Yeah.
Right? So this is how I got into AI. This is
Hmm.
why artificial intelligence became such a central topic for me. I was studying the brain. It
Hmm.
turned out that the intelligence of the brain is an emergent property of a neural network, of
Hmm.
interactions in a neural network, and the intelligence of large language models are emergent properties of interactions in artificial neural networks. Now,
Hmm.
in computers, you don't have actual neurons generating electricity and connecting with each other, but you simulate that,
Hmm.
right, with numbers and transfer of an activation.
Yeah.
That's what a neural network is. And so they share a commonality, right? So
Hmm.
they share this idea that they're emergent properties coming up from interactions in a neural network. So
Hmm.
the emergent intelligence, what is intelligence? Intelligence is the ability to flexibly solve problems.
Hmm.
And intelligence is an emergent property.
Hmm.
Now, there are foundational and deep and important differences between the intelligence of machines and the intelligence of humans and other animals.
Hmm.
But what they share in common is that they're both founded on neural networks, and they're both emergent.
Hmm. Incredible. You also write that thinking emerges from components that themselves cannot think. How can this understanding change the way we view human intelligence and creativity?
Yeah. So the ant example, right?
Yeah.
The ants don't know short and long,
Mhm.
but together in a colony, they know short and long.
Correct.
No neuron knows how to solve the binomial theorem,
Hmm.
but or write a poem or a love letter.
Hmm.
But working together, we can do all this.
Yeah.
So no single component. So this is
Hmm.
the core idea of emergence.
Hmm.
Now, does this leave, your question is, does this leave room for creativity?
Correct.
I have a very quick story for you. The
Yeah.
French philosopher Descartes was walking in a garden and he steps on a stone and a statue moves its arm.
Hmm.
And Descartes like, wow. He goes to a gardener, presumably in French. He asks him, what's happening here? And the gardener says, also in French, that look, there's a system of pipes, hydraulic pipes, that go, and as soon as you compress it by walking on the stone, they
Hmm.
connect to the statue's arm and the arm moves.
Hmm.
And for Descartes, this was, I would have maybe ignored this, but Descartes says this is how humans know how to move their hand from fire. He
Hmm.
imagined these tubes with fluids and all this signaling the brain.
Hmm.
Descartes was wrong in every detail,
Hmm.
but there was one amazing thing that he was right about, which is
Hmm.
you can understand human behavior mechanistically, like
Right.
you can understand an airplane.
Hmm.
Now, Descartes stopped short. Descartes said, these mechanistic things will explain reflexes, but they cannot
Hmm.
explain poetry and mathematics.
Hmm.
The thesis here is that we now understand how these same interactions can explain poetry and mathematics.
Hmm.
That we can understand. And this is not reducing it to some vulgar
Yeah.
material thing. It is,
Hmm.
we are we are entities in the universe, um, no more than the trees or the stars,
Correct.
but also no less.
Hmm.
And I see a lot of grace in this thought. Like we are like water flowing downhill, and we can understand why is the water going here and not here. We
Hmm.
can understand where our creativity comes from.
Yeah.
We can understand why people are different. We can
Hmm.
understand how these things emerge in a deep way.
Fascinating. You also describe AI systems as mind-like rather than truly mindful. How close are we, in your view, to building machines that genuinely begin to understand?
Yeah. So large language models are trained on predicting the next word. So if I take the word the boy jumped, if I take the sentence the boy jumped into the,
Hmm.
and I ask the large language model to predict the next word, before training, it'll say something silly like the boy jumped into the green,
Hmm.
which doesn't make any sense.
Hmm. Hmm.
But you train it by saying, no, no, green is not the right thing. It's actually pool or lake or swimming pool or whatever.
Hmm.
Um, right? And so what you do is you do this with the entire corpus of text that's
Yeah.
ever been written.
Hmm.
And the large language model is an emergent machine. It captures these deep patterns and can apply them in situations it's never seen before.
Yeah.
Okay. Now, is this an aspect of intelligence? Absolutely. Is it intelligence like human intelligence? In many ways, it's
Hmm.
not.
Hmm.
We learn with very small amounts of data,
Hmm.
sparse data.
Hmm.
Large language models require huge corpuses of data.
Yeah.
We learn very quickly with low energy. Large language models in the United States, 5% of the energy of the country is being used by data centers, which are
Hmm.
used to train large language models.
Correct.
So there are deep differences.
Hmm.
And one of the deepest differences is that we have goals, and goals, at least in part, come from our bodies.
Hmm.
Large language model by itself does not have goals.
Hmm.
So I don't think that we are close to what's called AGI, which is artificial general intelligence.
Yeah.
I do think that there has been the large language models are amazing breakthroughs
Hmm.
that will eventually rival the fire and the wheel in importance to human the human trajectory, the human
Hmm.
experience.
Hmm.
But I also think that said, these are not human-like in a deep way.
Mm,
Um, and in the book, I discuss what is human-like. They're both emergent properties in neural networks, and what is not human-like. Their
mm.
learning algorithms are different. They don't have bodies. They don't have goals.
Amazing. Great response. Your book also suggests that studying neural networks gives us insight into both ourselves and our machines. What personal insights did you gain when you were writing your book?
Right. So this is not a technical answer.
Okay.
Uh, but what I realized is that there is I don't know, this is Sanskrit, and this is a Tattvam Asi, right?
Yeah,
Which means I art
am
thou. I
that.
don't know, it's the
Yeah,
Upanishad or where it
yeah,
is.
yeah.
But I realized this in a deep way because your brain has some neurons,
Mm,
about 100 billion neurons. My brain has about 100 billion neurons.
yeah,
Now, these neurons in your brain and my brain and in the dog's brain do very similar things.
correct.
They have activation and they connect with other neurons.
Mm,
Basically, that's all they do.
mm, mm,
Now, but for accidents of experience, such as you've had some experiences, I've
mm,
had different experiences.
mm.
And so your experiences have connected your neurons in slightly different
Yeah.
ways, and mine have connected.
Mm,
And also, we were born with slightly different connections, just as some people are born taller and some people are born shorter.
correct. Mm,
But if you ignore those accidents of biological destiny and experience,
mm,
we are deeply alike.
mm,
The neural network view suggests that we are deeply alike. And and we discuss this in the book. And for me, what this has led to is an attitude of kindness.
mhm,
That's let's approach each other with the understanding that there is an entity
mm,
very, very similar to the entity that is myself. We
mm,
are both processes that exist for a brief time
mm.
on a rock circling a modest star in a one galaxy out of billions, maybe trillions of galaxies.
Correct.
And we have minds and we can examine the universe around us. So let's
Mm,
maybe have a attitude of kindness
correct.
towards each other because we are deeply one. And I was familiar as a child with this notion from
Mm,
our traditions,
mm,
but studying neural networks really helped me internalize what
mm,
it means to say that we are one.
mm.
And
Amazing.
by the way, I think it's not just two people that are one. It's
Yeah,
like we are one with the universe.
absolutely.
Yeah, the tree has slightly different cells, but we're processes that are
Correct.
unfolding in the universe.
Correct. No, no, your comment of Tattvamasi is so important. I am Brahman is another very important part of it, but that
Yes.
I'm going to keep for another conversation with you.
Okay.
But my next question for you, Gaurav, is that you often return to the question, why do we sometimes fail to act on our intentions? What insights does your research offer about human motivation and self-control?
Right. Another lovely question. So, Ashutosh, one abiding theory that humans have about why we do the things that we do is we think about them, we consciously think about them,
Hmm,
and and then we act, right?
correct.
But studying neural networks really revealed to me that we act not because of a conscious logic computer-like process. We act because activation
Mm,
from some neurons flows to other neurons, flows to other neurons, which finally flows to my muscle,
mm,
moves a neuron on my arm, and I move my arm.
yeah.
Or I move my leg and get up from the
Mm,
couch and go to the fridge to get a glass of water.
mm, mm,
It is not the conscious thought that I'm thirsty. It is a neuron that is looking at the amount of salt in my blood
mm,
and it's activating when there's too much salt,
mm,
which is connected to other neurons, which connected to other neurons, which are signaling the need for water, which is now with experience connected to the action
mm,
of me going to the fridge. All
mm.
of this happens
Yeah,
unconsciously.
yeah.
The conscious thought, somebody asks you, okay, why are you going to the fridge? Well, I'm going to the fridge because I'm thirsty. But that conscious thought comes after the process has already happened.
Yeah.
The conscious thought is really a justification for the action, which is observed rather than causes. And we know this because in neuroscience, we know what the person is going to do
Mm,
well before consciously they can tell us whether they're going to press the
absolutely.
right button or the left button.
Absolutely.
So, why do we sometimes fail to act on our intentions? Because we don't have enough activation.
Mm,
Intentions live on the conscious plane.
very
Activations
nice.
are brain wide, and sometimes there just is not enough activation
Mm,
to cause us to get up from the chair.
yeah, yeah, yeah.
And if somebody asks us intention, well, my intention is I want to get off the chair,
Mm,
right?
mm,
But it's
mm.
not the intention that makes us get off the chair.
Very well said. Time for two more questions for you. You've said that understanding the mind could help us, to quote you, get along better with one another and our machines. Could you expand on this?
Well, so we already talked about Tattvamasi, which is
Yes.
we are one.
Yeah.
So if you have this attitude of getting along with each other, then that because we're the same, we should lead with kindness.
Mm,
But I think it can also help us get along better with our machines because I
correct.
think the I am a big believer in checks and balances in society.
Hmm.
Um, because activations through evolution can be aggressive, can be harmful. So they need to be. This is the point of civilization. This is the point of culture. We put checks and balances on that. Our best impulses are amplified, and our worst impulses are
Suppressed.
renegated,
Yeah.
suppressed.
Mm,
So if the function of society is to put checks and balances on each other, I think the
mm,
function of the next few years is to put checks and balances on our machines so that
mm,
we can use them safely. Ashutosh, I think this is an inflection point for
mm,
humans.
mm,
Our bodies very soon are going to be part, I think we are one of the last generations that are purely biological
mm.
humans. We are going, like, our descendants are going to be part machine, part human in a very real way. There'll be little
Wow.
robots in our blood
Mm.
that can detect disease
Yeah.
cells and zap them.
Yeah.
So the pace of change is going to be profound. But just as over thousands of years, we've built societies in which people have checks and balances on each other. We have to figure
Mm,
out how to put checks and balances on each other and our machines so that we can make the human experience thrive over centuries and millennium.
mm.
But that will not happen without checks and balances.
Wow. Wow. And my last question for you, Gaurav. After finishing your book, The Emergent Mind, what new questions about human consciousness or AI are you now most eager to explore?
Yeah. So, Ashutosh, the amazing thing is that the emergent mind explains many aspects of the mind: perception, attention, learning,
Yeah.
decision making, context effects, concepts, even mathematics. It does not explain consciousness. So when I open my eyes, I am looking at something. And AI has a camera, but the AI is not having this experience that you and I have as we look
Correct.
at each other on the
Correct.
Zoom screen.
Correct.
So we don't understand consciousness. So I want to make that, there's something called the hard problem of consciousness in
Yeah.
philosophy.
Mm,
And that's a hard problem. Now, neural networks give us some insight into the problem that strong patterns of activation, they're the ones that usually lead to conscious experience.
mm,
What I am currently most interested in is motivation and goals. Like, where do
mm.
they come from?
Yeah.
Why are we sometimes energized and sometimes not? And my outlook is the same. We
Mm,
are processes. So we cannot explain this by some strange spirit matter or some atma. We have to explain this with neurons.
mm,
And I think it's possible because I think the next big revolution in AI is going to be AI that understands, at least
mm,
has in some limited constrained capacities, the ability to make goals.
mm.
And that's the challenge that I'm embarked on. Not so much consciousness, because I think that's a hard problem.
Amazing. And on that note, Gaurav, all that I can say is what an incredible conversation. I could just keep on listening to the amazing depth of knowledge, understanding you have about the mind. And it's also amazing how you are beginning to draw, and this is my personal passion, on draw from a lot of the scriptures.
Yes.
which are the Indic scriptures, which have seemed to have a lot of answers. Thank you for talking
Yes.
to me about your book, The Emergent Mind. Thank you for helping me to at least begin to explore so many aspects of neuroscience, and how it's amazing how you're linking that to artificial intelligence. And I loved your comment about how we probably are the last generation which are purely biological. Thank you for speaking to me. I look forward
Oh,
to
my
another
great
conversation.
pleasure, Ashutosh. My great pleasure. I loved your questions.
Thank you.
My hope and dream is that India sees a rebirth of science and discovery, and that we become again world leaders in that. And I
Absolutely.
hope computational neuroscience is one way to do that.
I'm
Thank
sure.
you.
Thank you. Thank you for listening to the Brand Called You videocast and podcast, a platform that brings you knowledge, experience, and wisdom of hundreds of successful individuals from around the world. Do visit our website www.tbcy.in to watch and listen to the stories of many more individuals. You can also follow us on YouTube, Facebook, Instagram, and Twitter. Just search for the brand called You.